scientist at the Data Science as a Service team in Dell EMC. Our team is located in Be'er Sheva. It currently includes 9 data scientists, all from different domains, all with advanced analytics in different domains: computer science, industrial engineering, neuroscience, and more. We usually operate in 3 different but overlapping lines. One of them is in internal project, internal engagements within Dell EMC. If it's developing recommendation systems for customer support or QA teams, developing anomaly detection tools or predictive models for disk failures and other solutions that are used by internal business units within Dell. The second line, which I'm going to exemplify today, is external engagements, both in Israel and abroad. And the third line, which is connected to the first two, is creating intellectual property and driving innovation in Dell EMC by writing patents and participating in academic and industrial conferences. So as I just said, I'm going to present an external engagement that we had about a few months ago. This engagement was with an external US sugar company, a big company. The business problem that triggered this use case was their need to predict the expected yield of each of their sugarcane fields. So they have thousands of sugarcane fields spread across the country, and they want to know in advance how to allocate their resources, human resources and equipment, so they can have the maximal crop with minimum costs. Okay, so this was the business problem. And actually, they had, at the starting point of this engagement, they had a model which was also pretty accurate, but it took very long time to build the model and run it. I mean, it took about 24 to 48 hours to train the model and run it every time. And this is mainly because they used the commodity was only laptop, and the model was it was run in R, code written in R, and they wanted to run it more frequently. I mean, it wasn't enough for them once a day, although we can all assume that it's not a real-time task.
What are you trying to predict exactly?
We want to predict the expected yield of each sugarcane field at each season in terms of tons per acres. Okay?
Why do you want to do it in, like, if it's for season, why wouldn't you do it a few times on an hourly basis?
Because they want, sometimes they want to get a prediction in the beginning of the season in September, and then they might say, okay, now we take those first 10 fields, and then in October they want to run the model again. And
September and October is a month, it's not an hour.
No, but it really frustrated them to run it sometimes for one day, and then it crashed. And
oh, okay, it's crashed.
Yeah, I mean, yeah, it might happen. I mean, if you want something for one day, we all know it can't stop.
Hardware.
Yeah. Okay, so yeah, so getting back to our objective, we want to get a prediction which are accurate and also faster. So I just give you the bottom line because it's a short talk. We managed to develop a model that reduced dramatically the model training and prediction time from 24 hours to 15 minutes. Of course, written in Python, and part of it also in PySpark. Just elaborate about it later. The mean average percentage error of our model, which is the evaluation criteria for this project, was 12.5%, which is slightly better than the model that they had. It was about 14 to 15%. And here you can see in this figure an overview of our solution. Basically, it composed of three main components. First one is data collection. It's not really a component, it's just a description of the data that participated in our model. We used both both internal data sources like historical data about soil type, planting system, plant age, and many more, which it was basically an Excel file of several thousands of records about past seasons. And we also had external data sources about, that we downloaded from public sources, weather data, which also was pretty small. And we had satellite images data from which we extracted metrics like NDVI and NDWI, which are indicators for yield. NDVI and NDWI can be extracted from images and indicate for the level of greenness of the leaves or the level of water in the field. So after collecting the data, it's digested by a data processing engine written mostly in standard Python packages like NumPy, Pandas, and we also used PySpark for the satellite images data. And after we vectorize the features, transform it, clean it, and engineer the features, the vectors are digested by a machine learning module, which is basically a competition among different regression models. And in the end, the customer or the user can get the prediction for the desired time as a dashboard which was developed by another team. Okay, so I just elaborate a little bit about the data processing engine and the machine learning engine. As I said, for the data processing engine, we used, for example, weather data for extracting features like a number of rainy days in a season, the maximum amount of rain in the most rainy day of the season, soil temperature, etc. And this was conducted by a simple and standard Python packages, as well as the historical crop data, previous year yield, soil type, etc. It was pretty simple. But then, and I think this is one of the important takeaways, at least in this kind of meetup, we extracted the satellite images features, the NDVI and NDWI, and it was pretty, like we say, in the big data zone. Okay, so I think that one of the good things of working with Python, at least from my perspective, is that you can develop pretty easily with the standard packages like NumPy and Pandas, where everything is very documented and well understood. And then when you have a more time-consuming task like extracting features out of images, out of many images for a given field, so you can move your code to the big data zone. And if you have a cluster or a suitable environment, you can write several PySpark codes and then continue developing with the standard Python code. Okay, so I think this is something that pretty interesting in the context of this project. And after we, and I just finished here, after we process the data, as I said, we have a machine learning module in which we conduct a competition between several regression models. The model is trained over data prior to 2015 and tested on data from 2015. And the, it was a POC, so we evaluated this according to this data. And after we choose the model that has the best performance on 2015, we give it as the model for the next season. Okay, so I think that the models can be divided to three families here. The regression models with the regularization, like discussed in the previous talk, ridge regression and lasso. Ensemble models, which perform better in this kind of problem. It was, I didn't say it, but it was 17 days engagement, so we didn't have time to fully understand the features. we needed a plug-and-play models. I mean, and in this case, I think that from my experiences, bagging and random forest are the best because they can eliminate the noise that you have in your features, and we had pretty noisy features since we are not a domain experts at agriculture. I think I'll stop here. If you have, what's sorry? Okay. If you have any question, you can catch us later about this project or any other thing. Thank you very much.
Okay, so this guy's an actual astronaut. He was in space, and he saw these spots of light in the middle of the day, in the middle of the Mojave Desert. So of course he tweeted about it, and some people had various theories. What can this be? Some say it's aliens, Bigfoot, and this one actually got it right. What he was actually looking at is our product. Nation zooming in. So this is they have voice. So this is Ivan Pasola, our largest operating plant right now. I'll shut it down because I don't want noise. Okay, so I'm Amit. I work for Bright Source Energy, and run the business of solar power, specifically concentrated solar power. So each of these squares is 4,000 dunams about, contains 50,000 sun tracking mirrors, heliostats. Each one of them is about twice this door, for example. You can't really see them in the picture. The tower is about, each spot of light is a tower 150 meters high. It produces each of them 130 megawatts, which is about the consumption of, say, 100,000 homes. Okay. So basically the mirrors are called heliostats. They direct the rays of the sun to the receiver. The receiver boils steam, heats the steam, and feeds it into a turbine. Okay, so the mirrors point the sun rays into the receiver. The receiver boils steam and heats it, and feeds it into a generator, which produces electricity. What I want to notice here that the receiver is not just a single block. It consists of panels. Each panel has they have various purposes. And for example, in this picture, you see these gray, black areas. They are just panels that are not being used. They are not fluxed. So that's the actual color. They are black, and the ones that are heated are glowing. So normally we want to point maximal flux at the receiver to produce maximal energy, which causes maximal electricity and maximal money. But you have restrictions. For example, the turbine is a delicate thing. It's spoiled. It likes to get its steam at the right temperature and the right pressure. And it cannot change, the levels of pressure cannot change really fast. And other parts of the system also have restrictions. If you heat some metal parts, they might bend, and they might cause damage. And you have to understand that these constraints, they vary in time. So what we need is a dynamic targeting systems that sends aiming points to each heliostat. Each heliostat is capable of tracking, automatically following the sun, but it needs to know where to point. So you have to assign targets to them constantly. The question is, can you keep the beam stable in cloudy days? So in cloudy days, this is how the radiation on a single heliostat might look. You see that it drops almost to zero and goes up again. You can't have this. You need to somehow keep the beam stable. So the answer is, of course, yes, but how do we do that? The aim is, as I said, the aiming system can direct the targets such that the beam will remain at the points we want it. Okay. But it needs to know the spatial distribution of the radiation and in the immediate future, actually. So this is how it looks. The green line is like a single heliostat, and the purple line is the average over the whole field. So theoretically, you have the right amount of energy. You just have to point it in the right direction. So previously, I said how it looks on a single heliostat, but when you look over the whole field, you can see pictures like that. Now, the actual data science, I couldn't get permission to show just in a short notice, but what I'm going to show is this tool, this little tool. Roughly how I made it was using a simple matplotlib hack. Okay, so because we have short time, I probably have to skip right to the code. But before that, I do want to mention what are the requirements. The targeting system, it works in time frames. It sends a set of targets every X seconds, every, I don't know, 30 seconds, minute. It sends a set of targets, and it knows to know in the upcoming time frame what will be on each point the average DNI radiation and the maximal on each point. So I basically have to create two maps. One estimating the average and so. Okay, so I had some Python code to research new estimators, but and I did some plot with matplotlib. But then we want to make. Oops, why can't I see the? Okay, so. Yeah. In a minute, I'm going to show how So first of all, it opens 3 plots. This is Voronoi. I have sensors over the fields, and this one, each of them shows. This one is the max estimate, and this one is the average estimate. And I can use the keys. If I press key down, it goes forwards. And I can go page down to go 10 frames forwards, and I can move to the beginning and the end. Basically, you all know matplotlib, so I won't go into details how you generate these plots, but I want to get input from the keyboard, and I want to update. I don't want to write GUI. I just want to take my existing code and to stick some stuff in and get this thing that can show, that can actually be used for people to research what happened during some events. They just input the time. They want to see what happens at this plant from this time to that time. It opens, you can configure what exactly to show in each of these plots. But it needs to keep these 3 plots in sync, and it needs to get the input from the keyboard, which is actually quite simple. Ooh. I have a link somewhere. Yeah. So. This is the points to the correct place in the matplotlib documentation, so you can look for yourself. And in the code, basically the figure object, you can get the canvas, and it has MPL Connect. You can just this is a placeholder into the event system of the backend. You know that matplotlib can use various backends, but whatever backend you use, this will get you to the event handler. So you can just insert a key press event. If I have more minutes, I can maybe, I don't know, maybe show some more parts. Okay. What? Maybe I'll show. Okay, so I have to slow this down. So you have the connect here, and the the pressure. The thing is, you don't have to. What I do is I made an object. These all plots they share a keychainer object. So instead of tying the handle to the onKey function of this plot, I'm just looking for the right function. It should be here. Oh, okay. It gets. Yeah, if you get in the plot function, if you get a keychainer, then it binds it to the keychainer. Otherwise, it binds it to the onKey function of this class. And the keychainer, what it actually does, it remembers which objects if you do the keychainer.onKey, then it will call onKey for each of the objects it's responsible for, and that's how you get interactivity. Okay.
Thanks.
No, I actually because I didn't get proper permissions. I did it all quickly, and I only got permission to present, provided I don't give handouts. But I think actually some code snippets I can give you to publish. Just the confidential thing is the actual plots and the actual data, because the data belongs to our partners, not only to us, and you have to get permission. Yeah.
And we know of anything like that for the Jupyter notebook?
I actually didn't try it. This was done something like a year ago, and Jupyter has gone quite a lot over the last year. So I don't know. It might even work now, because now it actually has interactivity. I didn't want to press it. I just made it work in the existing.
Great work.
Okay.
So the first situation which I encountered was at work. And what we do in MyHeritage, my team at least, is try to figure out with genomic data the ethnicity of a person. And I know nothing about genomics, so that was really hard for me. So I tried to read some literature about it. And I saw this great solution, which I found really intuitive. And it was written in Julia. And I know nothing of Julia. But I really wanted to use it. And the code was fairly simple, even for a newcomer. And basically what it does, you give it the genomic data, and it brings you back the feature which are most important to get the ancestral classification that you want. But I also wanted to get the p-values for each feature. So I just added this one line of code, and it was really easy, and I was really proud of myself. And I wanted to go from my little POC to actual data. But the problem was I had to get 15 million rows of data into Julia, and the read CSV function there was like taking hours. And I don't even know how much time it would have taken if I finished using it. And the problem with using CSV file is that when you got a lot of data, it's kind of slow to work with. And you also lose your metadata, and you kind of have to redefine everything. Sorry. But thankfully, people kind of understood that as data scientists, we work a lot with data frames, whether it's with Python, Julia, or R. And Hadley Wickham that built most of the packages which I use in R, and Wes McKinney that helped build the Pandas library, built this awesome, pretty awesome package for the feather format, which provides a binary columnar serialization for data frames. And it's designed to make reading and writing data frames efficient, and to make sharing data across data analysis language easy. And it really does. And just to show you a quick example from the blog post they posted after releasing the package. This is just an R code, and you can also find it in Python, which creates 1,700 megabytes data frame, and it takes about a second or so. And this was pretty efficient for me, at least for my needs. Sorry. So after that, I could go back to R and write the data as a feather format, and then bring it back to Julia. And it was, again, really easy. There's just two functions, just the write feather function and the read feather function. Yeah, so that was in Julia, but this is PyData, so let's talk about Python. In work, what I wanted to do was use scares, because everyone's using neural networks, so that seemed awesome, and I wanted to try it out myself also. But again, like I was pretty new to Python, and I didn't know how to make every column just as I wanted it to be, and the way I know how to do it in R. So I just used the feather format again to read the data in. Yeah, there's this slight thing of converting into NumPy, but then I could go back to Keras and do everything I wanted to do that all the awesome Pythonians do. Yeah, sorry. So these were just two quick examples from my work, but they're not really reproducible, and you can take it home and try it out yourself. So I did want to bring something that you could try out yourself. So this is just a really small example where I took this is Python code, so you can all be really excited about that. And this is just taking the iris data set and doing a short PCA with scikit-learn, which I really appreciate. But then when I wanted to look at the principal components, I didn't find Python plotting really intuitive to me, and I was really used to doing everything in ggplot, which I found really efficient. So I could just save the data of the principal components and take it back to R, to my comfort zone, and tidy up the data the way I'm used to, and plotting it out, and have my pretty ggplot. Yeah. So again, Feather is a great format, and it's fast, but what I found about it is that it's just a great way to explore things outside of your comfort zone in different languages. I really like scikit-learn, but I don't think I'll ever plot in Python, so that was a great thing for me. But I just urge you all to try it out and explore different languages when it's convenient and right for the situation. Thank you.
I have a question.
Yeah.
So, is it a better binary format for data frame in terms of speed of writing amount than other formats?
I don't really work a lot with big data. I work a lot with CSV files, so I just needed something that was quick enough for me. So I don't really know a lot of like,
So
are you talking like per cat or something?
HD5, I'm using HD5 with a gigabyte.
I don't like it.
It's pretty.
It makes me sad.
It's pretty fast. Like I'm not a computer scientist, so I don't know. But a lot of people use it for really big files. But it's also like in alpha, so you don't want to use it for production or anything like that.
So just to understand, whether it's just the format in which you save it onto the file, or also the library for manipulation?
So it's a format, but the package for using it is also called Feather, and I think it's in Python it's Feather format, in R just Feather, in Julia it's Feather.
And then it includes manipulations like compared to Pandas, right?
Yeah, it's compatible with Pandas and the data frames in R and data frames in Julia, and it's I think built on Apache Array. So I think a lot of other languages are going to use it as well. Thank you.
Hi everyone, my name is Gidi. I'm a freelancer data scientist. I'm very excited to be here. I do all kinds of projects, some of them in the recommendation system area, others in the image recognition. And one of my favorite clients is a startup that is called Personalix. They do out-of-the-box recommendation systems for e-commerce sites. So I'm going to show you a very cool Python package that is called LightFM. And it implements a recommendation system. You can all download it and use it, and it's really fast and easy to use. And it's gives you a modern algorithm. So in this talk, I'm going to start with some background on the recommendation systems field. Any of you have used recommendation systems? Okay, not many. The thing with recommendation systems that it's the most commercialized field in data science, but it's much less sexy than neural networks and images and stuff. So not many people know what happens in it. They, like many of you heard about the Netflix competition, and not much after this. So commercial things, Facebook use it, Amazon use it, everybody use it, make a lot of money of it. But what actually happens there? So I have to start with the Netflix prize. The Netflix prize was a competition of $1 million that took place between 2006 and 2009. The thing was, if you improve the Netflix algorithm by 10%, you will get $1 million. So in 2009, some people, one of them from Israel even, got this prize. The competition was over. And there was a model that this was stated as the best model ever for recommendation systems, and everybody should use it. So the model is matrix factorization. And from now on, I have many long words, so forgive me if I make mistakes. But this is the model. And the thing that you take a matrix of users and items, in this case, movies, ratings that the users gave to the movies, you decompose it somehow. And when you put it back together, you get predictions. Like here, you get prediction for Bob, item 1, you get 3.5. So an interesting thing here that the competition did include a lot of metadata about the users and about the movies, like age of the users or genre of the movies, but no one used, I'm sorry, not no one, but the winning solution did not use it. So it was like common knowledge from now on, so you don't need any metadata in recommendation systems. Just take this matrix, put it in the matrix factorization, and you'll have the best model. This was in 2009. So all the companies took it, tried to use it, and what did they saw? That the actual real-life data looks more like this than like this. A lot more sparser. You can see the percentages on top. Many users just come, do one actions. Many items don't have a lot of views or any views at all. So this model was not very useful. It didn't get very good results in things that are not movies. You know, when you go to YouTube or you go to Spotify, I don't know if you are really satisfied with the results. So something else was needed. And the new model that came afterwards in around 2011 was called factorization machines. So don't confuse, these are two very different models. The first one was matrix factorization. This is factorization machines. And this model's idea, it had many cool tricks. It is shown in this article, but I just tell the basic. That you take the matrix and you put it in a different format, like one hot encoding format. Like if you have the users here, you put them, every user as column, every movie as column. And then you can put the side features as columns as well. And you can use everything in one model and get better results than the previous model. So this is like now considered the state of the art. Yes, these models with some tricks upon it. People try to do neural networks and stuff, but they didn't really catch here. This is the formula of it, but you can read about it in the article. It's not very complicated, not heavy math, and it's people say it's really one of the greatest innovations in data science because it's like really something new, not like neural networks, which are old ideas, but run on better hardware. So now we get to LightFM. So LightFM is a package that comes from the industry. It comes from a company that is called, I had it somewhere, List. List is a fashion e-commerce company, and someone there took the factorization machines idea, implemented it in Python, got very good results. The library is very easy to use, like all the Python libraries for data science. You create the model, you fit, predict, you can evaluate. So now I will show you a short use case of this model. I will compare the factorization machines with the older model, which won the Netflix competition. So the data set is a data set of questions and answers from Stack Exchange. It has 62,000 answered questions. across 3,000 users who can answer 70,000 items, a really sparse data set. And we would like to recommend users other questions they can answer. One more thing that is available in this data set is tags. Like we have here an example. Here's a question: what should be the value of a feature if it can contain invalid cases? It is tagged as machine learning and classification. So I will try to run this model once with the side features and once without. This with, without. So I will need to close it for 1 second and to show you the notebook. Okay. So the first one is pure matrix factorization. I only put the data set of the matrix of the users and the questions. In a few lines of code, I run the training. I measured the AUC. And we see that we got the good AUC on the training set, around 90%. But when I run it on the test set, which I took earlier, I see we get really poor results of 35%, which is below random. So it's not, okay, it's not something I would like to use. Now, when I take the model with the features, it's the same as before, but now I put in the fit function the item features. It looks like this, the matrix. And then I get in the test set 70%. So it's not perfect, but it's much better than before. So every one of you, if you want to do any kind of recommendation system, if you have an e-commerce site or something, or just want to recommend music for your friends, you can take this package, put data in it, and run it, and that's it.
So last speaker of the night. Thanks for staying so late. Who here feels like he or she has a pretty good grasp of pandas? You can go home and have dinner with your families. So as you know, we saw a lot of interesting work today, but before the actual machine learning mojo, you have to do some pre-processing, you have to export the data, you have to do some munging, some cleaning up, and for me, the best way to go about it was pandas, and I'm a big pandas buff. So today, I thought I'll show a few tips and tricks that, from my experience, some people are not familiar with. I aim this talk at the intermediate user, and I hope that you'll find some interest here. So that's the table of contents. Hopefully, we'll get to cover some interesting things about me. As I don't know if it was said, my name is Alon Nir. I'm an economist. I left academia. I went to a company called Clairzen. Then, until recently, I was a guardian at Billguard, which was shut down, unfortunately. And now I am the chief data scientist at Honeybook Israel. I'm also the only one, but still. So let's go about it. Pandas. So usually you would use the Titanic dataset or the Iris dataset. I'm using the Airbnb dataset, which is basically some website called Inside Airbnb rigorously scrapes Airbnb all the time. They have some interesting visualizations and analysis there that you should check out. And then Kaggle took a subset of that of listings of Airbnb places in Seattle. So let's just get to it. Read it from a CSV for convenience. And the first thing that I recommend doing is look at the info, which would give you a sense of how many rows, how many non-null values, and the object types, which is extremely important when you look at the memory usage. So obviously, this is a toy data set with just under 4,000 rows. But when you get to 40,000, 400, or 4 million, then obviously the memory usage is very significant. And we can see that with just a few simple tricks that you can actually minimize the memory usage quite substantially. So the most important thing to remember is that we want to avoid strings. So if we can drop columns that are strings that we don't need them, and if we can evaluate other columns that are objects to other data types, then we will save memory. First thing to go about it is Booleans. So we have host is superhost, and the scraper didn't do true, false, or 1, 0. They used the actual letters F and T. And hopefully, unfortunately, Pandas obviously makes it a very easy task to convert that to an actual Boolean. So all I have to do is to pass, run host is superhost equals T. And obviously, if it's T, then you'll get true. If it's false, you get false. And then with a second, you just converted an object to a Boolean. Likewise for dates, you should evaluate to datetime. You can do it with the built-in toDatetime Pandas has, and you can also do S-type datetime. And if you are familiar with the dataset, you can actually parse the dates as you read it from the CSV. Side note, read CSV has like 50 different parameters you can pass, and they are very, very useful. And finally, one thing that many people are not very familiar with is to categorize the columns. So you are familiar with that? Okay. So basically, if you have certain values, certain columns that have just a very, very small subset of values that keep repeating throughout the database, the data set, then you should categorize them and save a lot of space. So for instance, the column room type has only 3 different values that are repeated 4,000 times. So with just as type category, you make that into a category instead of an object and a string. And you can see the impact. So I didn't even do these transformations to all the different columns, just for some of them. And from 3.6, I'm now at 2.7. So that's like a 25% reduction, just like that. And if I had done the other things, I probably could have achieved maybe 50%. So that's to get you warmed up, just to read the data and optimize it a little bit. Next, filtering and slicing the DFs. So the data frames, everybody knows about lock and ilock. By the way, ix.ix is being deprecated next version. So FYI, finally. What's cool about the categorization we just did is that you actually can do Boolean indexing with the actual category. So for instance, if we look at room type again, we have entire home, apartment, private room, shared room. And with set categories, you can pass a list, an ordered list of how much do you value the different values that field can get. So shared room is the lowest one, private room is a little better, entire home apartment is the best one. So you can do that, and now you can do some Boolean indexing on, for instance, any room that's at least as good as a private room. So if we just run that, we can see that simple slicing with operators on labels slice the data quite nicely. I think it's pretty cool. And one more thing is you can use regex. So for instance, if you want to look only on data for columns that have info about the host, so just use filter like host, and you see all different columns of host characteristics, like neighborhood, is superhost, and all that. And if you want to do something a little bit more advanced, then you do have regex. Like if you want to see the different prices, fees, and all that, then just pass regex, and that's it. That's pretty cool. Group bys. OK, so we all know, love, use group bys. There are a couple of things that I think are pretty cool. Some of you are probably familiar with the option to pass a dictionary and have different aggregate functions on different variables with a dictionary. And now if you want to flatten that hierarchical index to just one flat level, then it's obviously Python Pandas. It's one of the things that Pandas doesn't do with just a simple parameter, but you have to actually write 3 different rows of code. But you can do that. You get the level headers, the second level headers, you flatten them, and voila. What's really cool about custom argfuncs, about group bys, is that you can pass a custom argfunc. So for instance, if you don't want to use min, max, or whatever, you want to use something that you built yourself, then you can define a function, either or pass an anonymous function, and group by would work. So for instance, let's say for property type, we want to group by property type and have the bed types just pretty much count the number of real birds and then multiply it by 0.75, just for sake of illustration, and that would work. And you can also obviously define a more interesting and convoluted function that takes whatever you want and pass it inside the group by, and that would work. And by the way, one interesting thing to notice at the dataset is that for tenths, the median bathroom count is 0.5, which is interesting. I don't know. I don't know what happens there. So we did that. Oh, and date manipulation. So one of the things I really struggle with is dates, because sometimes it works beautifully and sometimes something breaks sometime. So let's just do a few date manipulations. We have 2 period. So if you have, for instance, daily records and you want to see the month and the year, just use 2 period. 2 period, pass in m, which is for month year, and the same date is transferred into month. And obviously there are lots. So you can pretty much pass whatever time frame you want, whatever frequency, days, weeks, quarters, like 5-hour intervals and so on. It's very flexible. And you can also do like date of week, which is 0-based, which is cool. Resampling. So what if you have daily records and you want to look at them on a weekly level? So you can use resampling. So that these are the daily records, and we can resample them to a weekly level, which would just take them and, in our case, sum all the records for that week, which is pretty cool. You can obviously use other functions as well. Now, let's say that due to some data corruption, you lost some of the dates, some of the weeks. Then you can see that over here you have 3, 10, 17, and you don't have the 24th of January, and likewise you don't have the first week of February and the first and the third week, and the last week of February. So Pandas has date range, which gives you, I'm almost done, which gives you, you can pass in 2 different dates, the start date, the end date, and the frequency. It will give you, spit out all the different date points. Then you can use that and then pass that in and reconstruct your data frame. So now, obviously, you don't know the values. You have the values for the different weeks, but you don't know what their values are. So you can use, you can use fill in A with backfill, forward fill, whatever you want. Probably a much more interesting thing would be you can do is like use the fit into a trend and all that, but that's not out of the box as much as I know. And finally, if you want to do, week on week, month on month, quarter on quarter differences, again, just one row in Pandas with the diff function, and there you have it. You can see that from the week of the 10th to the week between the week of the 3rd and the 10th, then we grew from 34 listings to 83, and then you have a difference of 49. And so on. I won't cover all of these because due to time constraints. As I said, just notice that IX is being deprecated, and there's a lot of unknowns about what's to come in the next version, which is probably because it's just being built as we speak. That's pretty much it. If you want the code, you can approach me. You can find me on any of the networks. If you're friendly, you can do the same for Facebook. And thank you for your time.